Hi, so we'll talk about how to design to represent a general tree. Now, to represent a tree like this, there are obviously many different ways. We'll talk about one of them, but it is by no means the only way. Now, regardless which way we take, though, the trees, they are all mainly composed of nodes, right? As you can see. And these nodes, they would have references or pointers that link to other nodes. So what kind of information should each of the nodes hold? Well, the most obvious ones are its children, right? So each node has a whole bunch of children nodes. So perhaps one way that we can hold the children of a node is to use, say, a list or an array of pointers that point to all the children nodes of a particular node. Now, if we take an approach like this, it's workable, but there's something that is slightly undesirable about this. And that would be that uh, each, because the number of children of each node would be different, than this list or an array, it would be a different size for each of the nodes. So again, it's workable, but it's a little better if the information that's held by each of the nodes is a fixed size. So we don't have to do things that are different. So in order to do something like that, we can actually take the inspiration from our linked list design, which it can hold variable number of items or elements in the linked list. However, we only need a pointer to the head of the linked list in order to access all those information. So what we'll do then is something like this. So for the node, say the parent node A here, we really just need a pointer to its first child node. And in order to get to the rest of the children nodes, then from each of the node can also have a sibling uh, pointer. So we will link all the nodes together, just kind of like a linked list. Now, obviously, we want all the nodes to be uniform. We don't want some nodes to hold only the first child attribute and some nodes only to have the sibling attribute, right? So all of the nodes should have first child and should have sibling. Now, in that case, then what is the sibling of the root node? Well, root by definition has no sibling. It's the top of the tree, right? So its sibling pointer would be pointing to nothing, none in this case. And for nodes that do have children, then its first child would be pointing to its first node, first child node, and those nodes which does not have child nodes, then its first child would point to none, right? And lastly, if it's the last sibling, then the sibling or the SIB pointer would be pointing to nothing. So that is the first child and the SIB references for a node. Now, is there any other information that we might want in a node? In other words, if we think back to linked list, was there one thing that we wish that maybe if we had it, it would have made our life a lot easier? Well, there was. So thinking back to the linked list, we could only do operations or like insert and remove after a given node, right? And the reason for that is that if we, let's say, have a current node, and if we want to remove that current node, then we have to go back to the previous node that points to the current node and make changes to the previous node. but we did not have a pointer or a reference to the previous node from the current node in the case of linked list. So in the case of tree manipulation, if that's still the case, then it will really make a lot of things very, very difficult. Therefore, in the tree node, we are going to have a reference to the previous node. So what that would look like is that if the node is a first child, then its previous pointer would be pointing to its parent. Well, because its parent is the one that pointing to it, right? So now for a node that is not the first child, then its previous pointer would be pointing to its sibling that is on its left. So C, the previous pointer pointing to B, and D, the previous pointer pointing to C here. And finally, there is this very unique node in the tree, the root node, that does not have a previous, or its previous pointer is not pointing to any other node. And root is the only node in a tree that does that. So a tree, while conceptually it looks like this, in our actual implementation, it actually looks like this instead. So a parent would point to a first child, right? Another parent, it will point to its first child. And then that first child would point to the next sibling, that would point to the next sibling, and so on. And at the same time, the first child node would also point to its parent, or the rest of the non-first child nodes would point to its previous siblings. So please keep this picture in mind as we talk about our actual implementation of the general tree.